Welcome. If you're a new dynamic positioning operator or DP operator, you already know your job requires absolute total concentration. But what happens when things go sideways? Suddenly, the bridge turns into a high-stress zone. Well, the secret to getting that control back actually lies in the IMCA Station Keeping Incident Form. Today, we're not going to treat this document like some piece of boring bureaucracy. Nope, we're going to look at it as a powerful investigation tool. By the time we're done here, you'll know exactly how to turn that post-incident stress into confident, total control over the reporting process.
Okay, let's dive into this. Here's how we're going to break down our chronological anatomy of an incident today. We'll start with incident classification, move into environment and equipment, look at chronology and metrics, then causes and corrective actions, human factors, and finally the pre-submission checklist.
Section 1. Incident classification, defining the event. So, accurately classifying the event is literally the absolute first step and the foundation of the entire report. It dictates exactly how IMCA and your management are going to interpret the form. We absolutely have to draw a hard line between a red alert and a yellow alert. A red alert, that's a full-blown DP incident. We're talking an actual loss of automatic control or position, the worst-case scenario. A yellow alert, on the other hand, is a DP undesired event. It's a glitch or an unexpected issue that caused or should have caused a yellow alert, but you haven't actually lost position. Trust me, mixing up an actual loss of position with just an unexpected event completely compromises the entirety of the whole database.
Now, there's a third category that really tends to trip up newer operators: DP downtime. Picture this. You're on watch, and you notice a position-keeping issue or a loss of redundancy. It doesn't warrant slamming the red or yellow alert buttons, but you've lost confidence in the system, so you stand down to investigate. You haven't lost position, but listen to me. Logging this downtime is absolutely crucial. It has to be recorded so the entire fleet can learn from that specific loss of redundancy.
Section 2. Environment and equipment status, capturing the operating context.
This is where we capture the exact physical and technical conditions the moment things went wrong. In Section 2, you're logging wind speed and direction, wave height, visibility, current, and, very importantly, the precise water depth. Why is this so critical? Well, it's just basic physics. The exact depth directly impacts the tension and geometry of your taut wire system. It also completely dictates the acoustic coverage and signal quality for your HPR during an incident. If you just take a wild guess at the depth, investigators literally can't recreate the mathematical model of the failure. Now, what's really interesting about this slide is the structured, step-by-step algorithm we use for flawlessly filling out the equipment block. You can't just scribble that the thrusters are working. You have to separate what was online, meaning actively selected for DP, from what was standby, which means it was available for immediate start but not currently running. So, for example, you need to clearly state that generators 1 and 2 were online while number 3 was on standby. Getting this exact configuration down proves whether your power management system was actually set up correctly. And that brings us right into sensors and reference systems. The MCF form requires you to map out the status of things like your gyro, wind sensors, and VRS using numbers. And guys, you have to be ruthlessly accurate here. There is a massive difference between a sensor just being available and being preferred. Preferred means the DP system's mathematical model is giving that specific sensor's data the most weight. Think about it. If your preferred wind sensor was feeding bad data, checking that one specific box essentially solves the entire mystery of the incident.
Section 3. Chronology and metrics, reconstructing the timeline.
Okay, sections 4 through 7 are all about hard, undeniable evidence. Did you know that in high-stress situations, human memory starts distorting the sequence of events in as little as 20 minutes? It's crazy. That's exactly why, for Section 4, where they ask for a sketch, my #1 piece of advice is this: collect digital data immediately. Do not try to hand-draw the ship. The very first thing you do once the vessel is safe is grab a screenshot straight from the DP system. Boom! Now you've got an indisputable, time-stamped visual record of your heading, the ROV location, divers, and your reference systems.
Let's move to Section 5 and see how this builds into the chronology of events. You're going to construct this timeline using the raw data from your DP, PMS, and VMS alarm printouts. It needs to read exactly like an airplane's black box. For instance, second 0, initiating alarm printout. Second 15, operator recognizes the issue. Second 45, corrective action applied. Second 90, position stabilized. Just walk through it step by step, completely grounded in the facts. Over in Section 7, the numerical description of the incident, vague estimates are absolute your worst enemy.
If you had a blackout, the form asks for the time to recover to the green watch circle in seconds. Writing down about a minute is a huge no-go. You need to dig into those system logs and write exactly 68 seconds. These highly accurate numerical metrics are what allow the whole industry to track if vessel recovery times are actually getting better or worse over the years.
Section 4. Causes and corrective actions. Analyzing and fixing the root problem.
Now we hit the investigation phase in Section 9, figuring out what actually went wrong. This demands a root cause analysis, and you cannot mix up your terminology here. The initiating event is literally just the first domino to fall, say a cooling pipe bursting. But the main cause? That's the underlying failure that made the pipe burst in the first place, like heavy corrosion from a skipped maintenance cycle. The secondary cause might be that the bilge alarm was ignored. Separating the immediate trigger from the true underlying cause is exactly how we prevent these things from happening again. In Section 8, you're documenting your corrective actions. Ticking these boxes proves to your management, the client, and IMCA that your vessel has a truly proactive safety culture. Did you modify the standing instructions? Did you run some immediate operator training? Maybe installed an additional alarm? This is where you show that the vessel didn't just survive an incident, it actually evolved to become safer because of it.
Section 5. Human Factors. The Power of Honest Self-Assessment.
Section 10 is arguably the most introspective and toughest part of the whole form because it asks us to evaluate our own actions during a crisis. So the crucial point is this profound question staring right at you. Would another DP operator react with a different set of actions? This demands brutal honesty and self-critique. If the answer is yes, it means your actions weren't standardized by training, you were improvising. And hey, admitting that doesn't make you a bad operator. It just means the training procedures need a serious upgrade so everyone reacts the exact same way.
This section also digs into things like potential task overload and excessive discussions. Were there too many people crowding the bridge? Were there gaps in the familiarization training? I really want to reassure any novice operators watching this. Logging task overload is not about incriminating yourself. Honestly, it's entirely about spotting systemic issues to upgrade the safety of the whole fleet. If you don't speak up and say the bridge was too loud to hear the alarm, the sterile bridge policy is never going to get fixed.
Section 6. Final Checklist. Verifying before submission.
A brilliantly written narrative is basically useless without the data to back it up. So here is your strict pre-submission checklist. Are the DP screen grabs attached? Are the physical DP, VMS, and PMS alarm printouts included? What about internal reports? Remember, an IMCA form without supporting digital data and printouts isn't an investigation. It's just a story. The printouts are your proof. Oh, and finally, make double sure that any confidential vessel or client data is properly protected. And this brilliantly illustrates the whole point. The IMCA form is not there to punish you. By applying meticulous attention to weather data, exact sensor configurations, and an honest assessment of human factors, you're doing something incredible. Accurate, honest reporting turns today's isolated incident into tomorrow's safeguard for the entire fleet. So the next time you sit down to fill out this form, ask yourself, what tiny detail can I log right now that might save another ship from a disaster tomorrow?